Okay, today we're going to do 9-5, which is about symmetry. And our goals today are to be able to identify line and rotational symmetry in two-dimensional figures. If you want to shorthand this to 2D, you can. And we are also going to be able to identify plane and axis symmetry in 3D figures. So, symmetry means that there is a rigid motion that will map the figure onto itself. So those motions are a rotation, reflection, translation, also glide reflections. So if we did one of those, our figure would be symmetrical on both sides. So we're looking at an example of line symmetry, which is also called reflection symmetry, which means that we are reflected across this line. It's even on both sides, and that line is called a line of symmetry. Rotational symmetry, or radial symmetry, is when we can turn it. So we can rotate it between 0 and 360 degrees, and it stays the same. And they show here that certain rotations will make this one the same. So if I turn it 90, 180, or 270, it's the same. So that's enough. I don't have to have every possible rotation. There's a couple, if I can rotate it at all and it would stay the same, then it's got rotational symmetry. Two things that we identify as well when we identify rotational symmetry is our order of symmetry, which is number of times a figure can map onto itself when we rotate it. So if we look at our example here, I can rotate this 4 times. It's a square, it rotates 4 times. So its order would be 4. And the magnitude of symmetry, also called the angle of rotation, is the smallest angle that we can rotate it to get that symmetry. Move that up. So, smallest angle for rotational symmetry. And it's easy to figure out what that is if we can figure out our order. So our magnitude equals 360 total possible degrees for a rotation divided by the order. So again, if I want to talk about this example I had of squares, if I divide 360 by 4, which is by order for how many times I can turn it, I would get 90 degrees. So that would be my magnitude. The last type of symmetries we're going to talk about are for three-dimensional. We have plane symmetry, if the figure can be mapped onto itself by a reflection of a plane. So we're cutting it right through the middle or maybe across this way. That would be plane symmetry. Axis symmetry is kind of if we can map it by a rotation. So here they show an example of a perfect cone. So it is symmetrical around this axis. Right, so we're going to look at some examples. I have a couple shapes here. We're going to determine whether or not it has line symmetry, and then draw all lines of symmetry and state their number. You don't have to copy the figure because it's already on there. So if I look at this shape, I have a parallelogram. Is it symmetrical? And it almost looks like it is at first, but actually if I think about trying to flip it across the line, like if I cut a line here, for example, and tried to map it over, it's not going to be in the same place. If I cut a line here, it's not even on both sides. So that's one way I can check if I'm not sure. So this one is no, it's not symmetrical. But the pentagon here is, and I can cut a line straight through the middle and have it be even on both sides. But that's it. That's the only line of symmetry that it has. And the rectangle, definitely symmetrical. I can cut it across the middle here and have two squares. And I could cut it across the middle here and get two rectangles. So we got two lines of symmetry there. Rotational symmetry. So we've got a star. Is this rotational symmetry? Yes. Where's the center of symmetry? Usually in the middle of your figure. So there's my center. State the order. How many times can I turn this and have it stay the same? 1, 2, 3, 4, 5. And that's based on kind of the fact that this star shape repeats 5 times. And then the magnitude of symmetry, so this is our order. 360 divided by 5, which is 72, is our magnitude. So that's how we can find all that information out about a rotational figure. Okay, this shape, it is weird looking, but it will rotate and map onto itself. And I'm kind of guessing here because I have this shape that repeats 3 times. That 3 is what my magnitude is, or my order, sorry. Order. So our magnitude, 360 divided by 3, it's going to be 120 degrees. I can turn it 120 degrees to map it onto itself. That is how far it has to turn to make 1. And our center is kind of in the middle again. This is generally your center. When we look at this image of the gear, again, center probably here in the middle. Yes, it's got rotational symmetry. What's our order going to be? So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Got 8 repeating shapes here. And then 360 divided by 8 equals 45. So there's our magnitude. All right, so last we're going to look at a couple 3D figures. Does this have plane symmetry, axis symmetry, both or neither? So looking at a sphere, I can cut this thing like straight down the middle here, and it's going to have axis symmetry. I'm going to have half of a circle on the top and the bottom. And I can also map this around a axis of rotation. If we put a line straight through the middle, the circle's the same all the way around. So this is a both plane and axis symmetry for our sphere. Now they have this lovely example of a flip-flop. There's pretty much no way that I can cut this flip-flop and have it be symmetrical on either side. Your feet aren't symmetrical, so it makes sense that shoes wouldn't be either. So in this example, we have neither form of symmetry. I'm going to move that back down in case you missed anything from the top ones. And this is finding lines of symmetry.